A little heads up, the first portion of the presentation today is going to be a PPT with some technical information, so it's a good time to take notes on that part of it. And the second half will be showing you examples on the Celigo of different applications you can use with the gating tab. So the first part's going to be more verbiage and technical detail stuff, so that's a note-taking portion. The gating tab, it's intimidating, but it's very powerful. You can reanalyze any of your images with a new application, and that's where you can have fun with the gating tab. So let's get started. What is gating? So this is just going to show you what are the high-level things that we're going to cover today in the training. So first off, it's objects detected. What you find in the Analyze tab can be further classified into subpopulations in the Gate tab. So that's where we're going to use the pixel parts of the graphic overlay outline to help us identify different subpopulations. You can use things like your size of your cell, the X and Y location, the fluorescent intensity, or the shapes to help you identify subpopulations in the Gate tab. So what kind of graphs can we create? We can use histograms, which is a one-dimensional plot, or we can use scatter plots, which is two-dimensionals. So two parameters or two features, and then plot them according to those measurements. And you can create more than one. You can have like as many graphs as you want. You just have to only select the classes. So next you want to draw an inclusive or exclusive gates over the plots of the scatter plot or the histogram of the subpopulation of the areas you're interested in that you want to see reported in the results. I know that's a mouthful, but basically the graphs help you see your population as a whole, and the gates help you draw things over areas of interest in your graphs. And the gates are actually minimums or maximum values of requirements for the objects detected. So for instance, area, you want to have cells of a required minimum or maximum value. So let's show you the different kinds of plots that can be created. So there's two plot types, as we mentioned earlier. There's the histogram, which is a one-dimensional plot. So in this example, we've plotted the objects on of their area. And so you can see that here on the x-axis of the graph, and then you have counts displayed on the y-axis. The two-dimensional is a scatter plot, and here we plot the green mean intensity on the x-axis and the red mean intensity on the y-axis. So this is purely looking at the fluorescent intensity of your objects plotted in a two-dimensional scatter plot. So what parameters can be used in the plots? What features basically are we going to be able to use to create our plots? So the top portion of the selectable items is the X and Y position. So if you wanted to locate your cells and only isolate or identify the ones in the middle or on the edge, you would create a scatter plot using these locations of X and Y of each of the objects, and it'll draw those according to where they're located on the image. You can use area. I use it a lot for the histogram to help me eliminate small particulate or really clumpy cells that are too big. Then you have morphometric parameters, form factor, smoothness, and aspect ratio, so that those are more shape descriptors of your objects. And then the bottom half of the selection is what is the intensity of your objects, the pixel intensity. So for instance, in this example, we have three fluorescent channels. So we have green, red, and blue. And within each of them, you have a mean and integrated. Integrated is summing up all the pixels in the outline of that object. And then mean is basically dividing that value by the pixels in the outline. So it becomes a mean integrated or mean intensity. And I'll show you two cases of where you would use mean and one where you use integrated. So what kind of gates can be drawn? So for the two plots types, we have the histogram. There are specific tools that used on the histogram, and then we'll show you scatter plot tools, which is a separate type of tools. So this is displayed when you create a histogram. This little icon box or bar is shown, and then next to the arrow, or to the right of the little arrow, you have this one that's called splitter, and it basically is dividing your population into two. So here we have a splitter on the area, and it divides it into a left and right population. You can put as many splitters on there as you want, and then just basically report on a specific population. I'll show you an example of that later in this training. And now on to the right of that is a min-max gate, range gate. I use this in the area histogram so I can define my population of interest, and I eliminate objects that are smaller than a cell or too clumpy, and I can't quite distinguish a single cell, so I'll get rid of really small debris or really large debris by creating this min-max range gate, where anything in between these two red lines is inclusive into this gate. Now on the scatter plot gate tools, you'll have an icon bar that's displayed like this. You can see you have the little mouse arrow, so you can basically click on the first, to the right of the arrow, you have this quadrant gate. In a scatter plot, you have an example here of green intensity on the x-axis and red intensity on the y. And if you just click on the portion in the very lower left corner, it plots two lines perpendicular to each other, which in there then creates 2 or 4 quadrants. Here you can see we've divided the population into 4 quadrants according to their location inside this scatter plot. Now the objects or the gates to the right of that quadrant are more there's a freeform tool, a rectangular tool, and an oval tool. And using that same scatter plot, you can see examples of these types of gates displayed here. So the freeform is probably the most challenging one, so I will spend a little time on that one in an example later in this training. If you don't like your gates, you can just click the X and it eliminates the X, or eliminates the gate. Okay, so another thing is in the expression analysis application, you have a customizing tool. So if you look at this icon bar, you can see a little piece of paper with a hand on it. This is a customizable tool. So when you click on it, it opens up a dialog box that shows you the current channel and feature and classes and allows you to edit the names that are displayed currently to something that's more meaningful to your experiment. So the first portion is the channel name. So this is each of the image channels that you've taken. So in this case, we have 3 channels, and they're currently displayed as target 1, target 2, and mask. And then the analysis outlines are the feature section that's right below that. That's the graphic overlay outlining your objects. And then the gated subpopulations are the classes that you can have reported in the results tab, but you define in the gate tab. And so if you actually double click on the word, say target 1, and you get an editable dialog box. So here's a display of changed names to something that's more meaningful. So we changed channel 1 to green, channel 2 to red, and so forth down the line. And the bottom, you can see the classes are more what we want to have reported in results: GFP, RFP, YFP, and no fluorescence. We'll go through this in the training shortly. Okay, so assigning classes by checking the box. This is probably one of the biggest calls I get, most frequent calls I get from customers. Why didn't I have that reported class I wanted? Well, it's because the checkbox probably was not checked. So when you change the name for that class to say RFP, you also have to put a check next to that box for that population to be reported in the results tab. So you can see the pink color is basically population 2. It's the upper left quadrant in the scatter plot, you would want to check that as RFP. So it would be reported as RFP in the results tab, and so forth with the other populations. So here's an example of the image that's coming from this scatter plot, and you can see the outlines match the colors of the objects that are falling within the quadrants in the scatter plot. So we have our RFP is pink, our YFP is yellow, and our non-fluorescence is blue. So you would check the corresponding boxes in this left-hand column to properly report your classes in the results tab. And if you delete your gates, just FYI, if you delete your gates, the check boxes will be deleted as well. So if you create additional gates, you'll want to make sure you again check the proper boxes to what you want to report. So, and again, you can delete by clicking the little red X's above the scatter plot for either the gates or for the graph itself. So here we're checking the RFP and then the YFPs for yellow. And then you would have to scroll down to get the non-fluorescence and the GFP, but we'll do that later in this training. And then the additional class is actually further down, so you would just scroll down to get to the GFP population. So what applications can actually use gating? So this is an important page. This is one that you probably want to take notes on. So the 4 applications this displayed here only allow you to report a total class. There's no 4 additional things, just only total. The data output for a total plus 1 class, that would be DNA synthesis and cell secretion. That allows you to have 2 things reported. The output that allows you to have total plus 4 classes are all the expression analysis suite, and also the colony suite and the tumor sphere zonal. So I spend most of my time on the expression analysis in the colony suite. I rarely ever use the single total only reportable or the total plus 1 class. Okay, so now let's get into the Celigo software and show you how to do this on the software. So first we're going to look at a 3-channel application, and we're going to load or create a new analysis with merge in the expression analysis. So what we're going to be looking at are GFP cells, RFP, and YFP all stained with Hoechst. So we have 3 different cell populations, but we've imaged in 3 channels, the green, red, and blue channels. So here you can see the YFP cells are yellow and actually come through on both the green and the red channel. So if you turn on and off the green channel, you can see how the yellow cells turn red. That's where you can see both, and then the green only come through green and the red only come through red, and then the blue comes through only on the blue channel. So let's personalize this experiment or scan or analysis with this little customize button. The customize button again is available in the scan tab, analyze, and gate. So here I'm changing the channel names and the feature names to reflect what we have imaged here. So we have green, red, and blue. And then for the classes, I want to report an RFP, YFP, and GFP population, and also a non-fluorescent population. Now, in this state, we're actually going to be, or now you can see that the names of the image display channels and the graphic overlay are now displaying what we've just edited them to be. And again, this is the merge application, and I'm using this because it allows me to look at or use the graphic overlay to outline the cell bodies for the Yfp is much bigger than the nuclei, and that's going to help me decipher those cells. So it creates one single mask. Next, I'll click on the gating tab and we'll move over there, and then we'll select a well. Notice how I did not click Start Analysis. That would actually just go and analyze only. So no populations would be displayed. We have to set the subpopulations in the Gate tab. So we just clicked on the Gate tab up top to get to this page. So once you click on a well, the image is displayed and the graphic overlay is now color-coded in blue. And we can turn on and off the graphic overlay and see how the objects are now outlined in blue. First thing we'll do is create a plot using this green plus sign. So click on the plus. And what I want to do is eliminate small objects that are not cells. So we're going to use a histogram with area. So for the source population, it's obviously one population only. It's everything outlined in blue. And this plot type is going to be a histogram. And then the plot parameter is going to be area. I want to eliminate small debris that is not a cell and clumps of cells that are not segmentable or individual segmented. So we'll click on area, and this will be displaying a one-dimensional histogram. So here is our histogram, and now we're going to select the range tool. So that's the one here with the two red lines we need to create. So we'll click on that and then click and drag over the area of the population you want to identify. Click and drag over that peak histogram and then release. You'll notice two red lines in between them, it's now pink. Once you release your mouse, every graphic overlay inside those two red lines is now outlined in the image as red. So this is now color-coded red on the left. That's our population 1. This is now going to be our new total. So checkbox total, and that'll be the denominator for the percentages that are displayed in the results later. So we now are eliminating those small particulates that are not really cells and unsegmentable or clumps of cells that we can't quite distinguish one from the other. So that's over on the right side of this red line. If you need to adjust it, you can actually click on the red line with your left mouse and move the min-maxes to a location that's more appropriate for your objects in the image. So now we can create a second plot to help us distinguish the red, yellow, and green cells from each other. So we'll click the green plus sign, and now the source population is going to be this new one we created, population 1, which is now our total. That's the default that comes up. And then we're going to pick a plot type, which is going to be the scatter plot. And for the plot parameters, we want to be looking at the green mean intensity for the x-axis. So click on the down button and you can see all those parameters displayed we showed before, and you're going to look halfway down for green mean intensity. So this will be the pixels inside the graphic overlay and then divided by the number of pixels in the outline. That's the mean intensity. And now for the y-axis, you're going to want the red mean intensity. integrated is actually just summing up all of the pixels in the graphic overlay, and so that number could be infinite, but the mean is only within the camera range of 0 to 255. So you can see on the scatter plot, we have the red mean intensity on the Y and the green mean intensity on the X, and the range of this graph is from 0 to 255 because it's the mean intensity. Next, we'll click on the Quadrant Gating tool. And we want to click on the graph just once in the space that we consider currently where we would want the quadrants to be created. And it draws two perpendicular lines, and they're color-coded. Automatically it goes to these colors, but you can adjust them, and I'll show you how. So we have this mint green population, which is truly our red Yfp cells. So let's change that color for the RFP to something that's a little bit more relevant. So if you click on this drop-down menu, you can see a color palette that's displayed. So let's pick pink, because in the previous area plot it was already red, so that color's taken. And don't forget, this is the key. You need to check the box next to the class that you want to be calling this. So we're going to make this our RFP population. Now this diagonal cluster of cells are our Yfp cells. They actually are displayed in the green and red channel. And this is the aqua blue color, which I'd like to change to yellow because it's a yellow cell. And then we'll check box the Yfp. And then we have non-fluorescent cells, which are currently outlined in blue, or like a royal blue. And as I scroll down, you can see the fourth population, but let's adjust this royal blue to a different color because the original graphic overlay was royal blue. So let's make it aqua blue. And then here is our Yfp cells that is on the x-axis. And let's change that to a bright green color. Now, every time you're changing colors, you can see the graphic overlay on the image is actually updating as well. We also want to check box that non-fluorescent. If you don't check it, it won't be reported in the results. So we need to scroll back down. And then for the green population, let's check for the Yfp for green. Now, as you are finishing identifying your populations here, I like to just move around on the image and turn on and off the graphic overlay to make sure that the cells in the image are properly identified. So if you need to adjust this quadrant, you can just click on the little square that's in the corner or in where the lines intersect, and then just click with your left mouse and drag it around. But this population is pretty distinct and easy to see, but you can see that it's doing a good job. My RFP cells are very faint, so you can see on the scatter plot, the objects don't get much brighter than 75 as far as pixel intensity, and my Yfp are super bright, so they go all the way up into the range of 250 for the red and goes about 150 to the green. So that's when you're actually acquiring the images. You want to make sure your pixel intensity exposure gives you the middle of the camera range. I always talk about 150, 125 for your pixel intensity of your objects. Now, when you click on that results button, you can see the data is displayed for this particular well according to this gate. So it allows you to kind of see how your results will look. You can see that the total count, which is 602, is actually coming from this red population here. It's not the analyzed graphic overlay, but it's now this red outline. And then here's our quadrant displaying our 4 different subpopulations. Okay, now I want to show you an example of the cell cycle scatter plot. So this is a popular application for identifying the cell cycle phases. So you're just imaging in 2 channels. So here's an application that gives you synthesis and total only, or you can do the target 1 plus mask, and it's the same image set. It's just allowing you to report more classes than just synthesis and total. It'll give you 4 classes to report plus the total. So here, let's first customize the channel names, feature names, and identify the classes we want to report. So click on that little hand icon. And so the first channel is green, which is our BRDU Alexa 48 stain, and the mask channel, which is our DAPI blue stain. Every nuclei will get stained with the DAPI because it's a fixed cell. And then the features will get the same name, and the classes we're going to report are the G1, G0, the synthesis, and then the G2M phase. Okay, now for this application, because we're using a mask, I only check a couple of things. I want the well mask on and separate touching objects. So when you have nuclei that have just divided, they're pretty close together, so we'll want to use separate touching objects for that situation. But next, we'll just select the wells we want to analyze and then click right onto the gate tab, and we'll migrate over there and then click on a well to start viewing the image and the graphic overlay according to those analyze parameters we just set up. So now you just hover your mouse over the image and scroll in with your mouse, kind of like Google Earth. And now you can see we have green and blue images, and there's some green particulates that are showing up. That tends to happen sometimes when the Alexa 488 can precipitate, but because we're using the mask application, we're only going to be looking at objects that have a blue stained nuclei. So the graphic overlay is outlining the blue nuclei, so that helps us isolate to be the only objects we look at, and we ignore that precipitate. So clicking the plus is the first thing we'll do to create a new plot. And the first one we'll want to make is a histogram. We want to redefine a total to eliminate small nuclei or things that didn't get segmented or divided properly. So the plot type will be histogram, and the parameter will be area. Same thing that we did in the previous example. And then we'll do the min-max range gate. And then we'll click on the left area of the histogram population and then drag over to the right and then release. If you need to move or adjust it, you can either click on the red lines or even click in the middle of the line that's pink area and move it left or right. So now this is what I want to call the new total. So we'll check box on the left-hand side. This red population is our total or denominator. Anything outside is going to be eliminated or not included in the next plot. So click the plus sign, the green plus sign, and then the plot type will be a scatter plot. And for the x-axis, we're going to choose blue integrated intensity. So this is the pixels from the blue channel, and integrated means it's all of the pixels summed up. So this number could be infinite. And then for the y-axis, we want to look at our green channel pixel intensity, or the BRDU staining, which is, in this case, Alexa 488. And then click OK. Now, all the objects from that new total are still displayed in graphic overlay red color. This is looking good as far as a scatter plot, but let's click this little adjustment icon to adjust the scales of our graph to display a log scale. So that's using these two check boxes here. And that's looking much better. And then we can adjust the size of our little dots to be a little bit smaller so it's easier to distinguish very tight or dense populations. Now this is what we call the cell cycle horseshoe. And you can see when you scroll in with your mouse on top of the scatter plot, just scrolling in, you can zoom in and separate this scatter plot a little bit better. And you can see the distinguished populations. So we have our G0, G1 population in the lower left. So we'll, I think in this case, because we have a shift that goes up to the right, we're going to want to use the freeform. Now this is a little bit challenging. It's kind of a little more artsy. My suggestion is when you click on this icon, do a quick circle on the scatter plot to create a small thing, and then just click on the little small squares to adjust the shape. That way you only have a few squares to move, and you can ignore the rest of the other ones that you don't need to really worry about. So alternatively, you can just draw around the population, but it makes it a little bit more difficult to edit it. Having a small circle, then you can just pick on the little squares and draw the shape that you want exactly using these little squares on the thing. So on the left, I've put some notes on your mouse. You'll notice if you hold down the scroll button and drag, the scatter plot moves around. That's just holding the scroll button down. And then if you hold the left button down on your mouse, you can drag the free form around. So that's taking use of your mouse buttons that you may not have used before. So you can hold the scroll button down and move the whole graph around, or hold your left mouse button down to just drag the gate around. And then using these little boxes on the gate, you can make the shape exactly how you want. So this is a green synthesis, so we're going to make it that bright green color. A lot easier to see also on the graphic overlay. Okay. So once you have that one, that's probably the more difficult one to set up. Then you can, don't forget, you'll need to check box. I guess we'll make another free form with the G0, G1. It's a little bit smaller population, so this should be easier. So again, just click on the small boxes of the gate and expand them to make it around the area of interest in the scatter plot. And if you hold the left button down on your mouse, you can move the gate itself. I tend to make these gates a little bit bigger than the population in case you have more cells in one well that might be showing up a little bit beyond the pile that you see currently in that G1, G0. And now when I've drawn this G2M, it comes up with blue. That's hard to see, so I'm going to change it to purple. And actually, let's just move that whole gate down a little bit, and then I can move the little squares up. Okay, so now you can see we've outlined gates over the area of the scatter plots that we want to report, what we need to do now is checkbox what we want them to be called in the results tab. So the purple is the G2M, the aqua is G0, G1, and the green is the synthesis. And then as you are noticing on the right side, every time we move a gate or change a color, the graphic overlay on the image on the right side is also updating. And you'll notice that the outline is actually right around the nuclei. You can see it's very close to the nuclei, and we're ignoring any precipitate debris because it doesn't have a nuclei. It's nice to also click on replicate wells just to see how the scatter plot and your gates are going to perform when you analyze the whole plate. So basically you're designing your gates here, and it's going to be applied to every well when you click start analysis in the lower right corner of your Celigo screen. Clicking on the results here is just displaying the well that's currently displayed, so you can see what the populations are going to be reported on in the results tab. So if you're happy with where the gates are, you can at this time click start scan and then analyze the entire plate this way. Oh, also it's good to have a treated well so you can see how non-synthesizing wells are basically going to look with your scatter plot. So here we've done a good job setting up our gates, and this is an acetylcholine treated well. It's an A549 lung cancer cell line. Okay, now I want to show you an example. Say for instance you've got a viability assay where you stained your cells with calcium PI and hooks, but you really want to have bright field in there too, just for purposes of observation. So let's reanalyze or image and analyze this in a 4-channel application and customize the channel names to green, red, bright field, and we're going to use blue on the hooks will be our mass channel. So we're only going to look at the area of the nuclei as our mask, but we're going to ask, do we have green or red in the area of that cell? So here I've updated the labels for the channels and features to represent what we have on their image. And you'll notice I'm looking at a 384 well. I'm going to recall some analysis settings that I've used before. So it's quick for me to just pull this up. And next, we'll just click on the gate tab. And then we'll click on a well to view. And excuse me, you'll see I have a very compact well. Basically, this was probably 4 days where the cells had been treated and grown to pretty dense population. So this is why I wanted to use the hook stain to actually get my cell number. I couldn't use bright field because they're all crisscrossing on top of each other. But using the hooks channel as my mask allows me to identify the nuclei only. So at this point, we're going to create a plot. So use the green plus sign. And you can see when I turn off the bright field, even though I have calcium stain, the cells are probably dim. There may not be super healthy. So we'll first create a plot of a histogram and use area as our x-axis parameter. And I want to eliminate any small particulate or large clumpy cells that I can't quite distinguish. So we'll do the min-max range gate. Click on the left side, holding the mouse button down and drag across to the right. And then release. Now you can see very small blue dots. Those will be excluded in my total, so I don't have those counted in my total, but I need to checkbox that total at the top. And then the large clumpy cells, basically if you want them, you can drag the red line over and it'll include them. So let's checkbox that as total. That'll be the denominator for our population percentages. I'm still eliminating the small blue items that are not really blue nuclei. It's just probably debris. And then we're going to click on the plus sign again to create a second plot. And this one will be a scatter plot. The population 1 is what we just defined, and that's where our source population is coming from. And then plot type will be scatter plot. The x-axis, we will use green mean intensity. That's our calcium live stain. And then we'll have the red mean intensity be our x-axis. And mean intensity, again, is dividing it by the pixels in the graphic overlay area to give us a mean intensity. So the plot will be within a range of 0 to 255 for both axes. So now you can see we have a cluster of dots on the scatter plot, and it's hard to see, so we can adjust the plot settings according to this little icon here. And we can actually type in or fix the axes if we want to have it always stay at a certain viewable range. So in this case, we really have a green mean intensity in the range of 100 to 200. So let's change the value for that minimum or the maximum to be, actually, here's the red mean intensity. I really want the green to be at a minimum of 50, displayed at a 50 to 250. So we'll change the minimum to be 50. And that'll spread apart that cluster of dots on the image or on the scatter plot. It's a little bit easier. Maybe it could have been a little bit more specific, like 75 or something, but this is good enough. How about we change the size of our dot on the scatter plot to be smaller? Okay, that's easier. Now we can see a little bit more separation. Let's use the rectangle tool and draw on the plot. So you actually, I'm going to draw a green box. I'm going to draw it up here in the blank area just to show you. Draw and drag it to the right in a diagonal. And what I want to do is create a box around the live population down below. But first I'm just going to design it up here in the blank space to the shape that I want. It's kind of covering the size, and then I'm going to click in the middle of it and with the left mouse down drag it over to the live population, which is our green cell population down below. And then we'll change that to bright green. And to adjust this shape, we can use the little squares on the corners to be properly seating to the size where we really need to get the detail of where the gate's sitting. Okay, so now the graphic overlay on the right is updated to show the cells that are stained with green are now outlined in green. Anything outside of that is colored in red. And now we'll draw another box. And this one's we're going to identify the red PI stained cells. So you click on the graph and hold your mouse button down and drag in a diagonal. So this is anything that has red fluorescence or PI staining. Now the objects will update with blue aqua outline on the image. And then the red is actually the ones that are sitting outside both of those boxes. We'll color code this blue into a dark red so you can see that's more of the red dead cells. The space between these two boxes are objects that are not identified. They're currently outlined in this red from the total. We can change that to a color because that might be misleading, maybe to purple. So now when we go back to our scatter plot, you can see those bright red ones are now that purple color. And we can use the red for our dead cells. And that's more logical. So let's check box. That is our dead population. And then the green is our live population. So anything that's not outlined in green or red is sitting outside of those boxes. And that's why you see large clusters that are outlined in this purple color are sitting between those two boxes. If you want to get those cells included, we can dial in on the scatter plot. And if you click on the results, it will display what's currently shown from these gates on the scatter plot. You have about 89% or 90% alive and 8% dead. So the population that's actually in between that is very small. Let's click around on another well to see how does it behave. So this well is about 87% live, 10% dead. Now, if you want to dial in, you'll want to change the graph display on the red axis so we can open up the adjustable dialog box here and make the maximum for the red axis to 50, and then it'll pull apart the graph here so we can actually edge our gates for the dead down a little bit closer to the green so that the objects between the two of them is now covered by one of the two populations. So this is how you can fine-tune where your gates are placed so the objects between the two gates can be picked up a little bit better. But as I'm adjusting these gates, you can see that the results on the right column are updating, and they're not changing that drastically. So the few cells that you're not getting between these two gates is not that big of a deal. But if you want to, you can adjust these to better fit your population. So it didn't change all that much, but you can see that there's a few cells that are not collected. That's okay. Okay, so here we have just moving around on the plate with the different drug treatments. You can see how the populations change, what drug treatments are really affecting the cells and which ones are not. This is a really dense well. And then you just click Start Analysis and it applies it to the whole well. Now I want to show you a larger type application, colony size. We're going to separate these colonies that are displayed in the image according to their size. We're going to have small, medium, and large colonies. So let's load this single channel. It's a bright field image on to the Celigo, creating a new analysis. We're going to click on a well. We're now in the Analyze tab where the whole well is displayed. Because it's a large application, the whole well is displayed in the Analyze tab. This is a 96 well, black wall, clear bottom. We'll scroll in. These colonies have been growing. I think we had 3, 6, and day 7 of the plate imaged. You can see the colonies when you turn on the graphic overlay, the default settings are pretty close, but I know that I've worked on these type of applications before, so I had some saved settings. So we'll click on colony detection. That's my saved application settings for this type of scan. And now the graphic overlay will update according to those settings, and the outline will properly identify the cells according to that. So we've got a well mass that's slightly shrunk. We've turned on separate touching colonies, and we maybe moved the minimum thickness to 15. It's like a rounding factor. And we've done an aspect ratio, so we only want round objects, not long things. It's doing a pretty good job. So now we'll select the wells that we want to analyze, which is the whole plate, and we will analyze them with these settings. And then we'll move over to the gating tab by just clicking on the gate tab in the workflow diagram up top. And then we'll select the same well that we just were observing. And then when you scroll in, you see the graphic overlay is now coming up as blue. This is, the gate tab always starts out with a blue graphic overlay. The first thing we'll do is create a plot with this green plus sign. And this one will be a plot type of a histogram. The source population is the total all from the analyze outline. And then we'll use the area as a parameter to plot the objects. And we'll use the splitter icon. So we're going to use the splitter 2 times on this histogram. We'll click on it and then click in the histogram on the lower end of this histogram. You can see the left is all red. Those are our small colonies, and then the green ones are to the right of it, are in the green outline. So we can click on the splitter tool again, and now we're going to split the population between the medium and the large colonies. Just clicking on the histogram again, you create a third population. So now you can see we have red is small, blue is the medium, and green is the really large colonies. So let's change the color to something a little bit more distinguishable. So we have like a purple outline now. So we have our 3 different size colonies displayed. What we need to do is change the word class 1, 2, 3 to small, medium, and large. So let's click on this little customizable icon and just highlight over the word class and change it to small, and then class 2 is medium, and class 3 is large. And then click OK. The screen will update to those new words, and then we just check what we want the classes to be called. So this red population is our small population, blue is our medium, and then this purple population is our large class. So that's how you can create multiple populations in a histogram using the splitter icon. And clicking on the results gives you an example of your colonies counted and the percentages, and also the area for each of those populations. And that would be the mean area. So notice the mean area is of the whole total population. The classes are below that, so that would be small mean area, medium mean area, and large mean area. So then once you're satisfied, you would click Start Analysis, and the entire well, all the wells will be analyzed this way. You can move the red line by just clicking on it and dragging it left and right, and the graphic overlay will update, and so do the results. Just clicking on it with your left mouse button, hold and drag. Okay, so we basically have covered a lot of different types of applications that can be further defined in subpopulations using the gating tab. So we've identified the objects that we first identified in the Analyze tab and created subpopulations according to their size, their fluorescent intensity, or even their shapes into subpopulations. You also can do X and Y location, but we didn't cover that one today, but you get the idea. I've shown you how to create histograms and scatter plots, and I showed you how to move the graphs with your mouse buttons and drawing gates over these subpopulations using the left and the scroll button. And then you can create minimum, maximum values, and you can adjust the scales of your graphs. Also creating how to name your subpopulations with the little customizable icon. So we've covered a lot, and so if you guys have questions at this point, we'll open it up to you guys. If you just want to type in on your screen a question, we can help answer it. Or if you have questions that come up later, you can contact us at support@nexcelom.com, and we'll be happy to get back with you, or even have a remote session if you need some online time with us.
Great, Sarah. I think that was a wonderful presentation. So we are starting our Q&A session. So if anybody has any questions for us, feel free to type them into the questions bar, and I can read them out loud to Sarah, and we can get the ball rolling. And while you guys are typing those in, I just want to remind all of our attendees that there is a survey that you guys can fill out at the end of this webinar, and feel free to let us know if there's any future topics you guys would like to see for future webinars. We'd love to hear your input and your topic suggestions. And you can also check out any of our user training webinars on nexcelom.com under our help and training page if you guys feel like you would like to watch more Celigo user training webinars and what we've covered in the past. So I'll just give you guys another minute or two to type in some questions, and we'll check those out. Okay, so I'm not really seeing any questions come through, so that will conclude our webinar for today. So I'd like to thank all of our attendees for joining us today. I really appreciate that. And Sarah, I think you did a wonderful job, and we hope you guys will join us next month for our next Celigo user training webinar, and I hope everyone has a great day.